Okay, this is P-looping number 4 video, and what we're going to discuss here is how to take a value in inches and convert it to the tick value to use in our while loop. So currently we have ticks as a variable, and I think in our program ticks is equal to, let's say, 3,000, and then we have a while the sensor value of the encoder is less than ticks. Then perform the auto straight and the P loop to slow it down. What we want to do is we want to then make this ticks variable, instead of a number, we want it to be based on a distance in inches. So we're going to have another variable called dist, and let's say we want to go 5 feet. So this would be in inches, and we need to come up with an equation to convert inches to actual ticks. So it's no longer going to be 3,000, but some equation that relates these two together. If I look at the geometry of my robot, and I have my wheel, one wheel rotation is equal to the circumference of that wheel, which is 2 pi r, or pi times the diameter of the wheel, so which is equal to the circumference of the wheel. So I'm going to set up this is a conversion factor to go from rotations to inches, or inches to rotations. And then also, if I have encoders on my motor, so if I have a motor attached to this and I have an integrated encoder on it, back here, the integrated encoder that's set up, if I have a 269 motor, that value I think is like 240.448 ticks per rotation. And I found this on the VEXrobotics.com website for the integrated encoders. If you're using the quadrature encoders, which are the red kind of boxes that go on the motor shaft, those are 360 ticks per rotation. And then if you use a 393 motor, those numbers are different. You just need to look those up and reference those to figure out how many ticks per rotation. I'm going to set up some constants, this one being one of them, and also the diameter and circumference of the wheel also is constants for my robot. And then if I ever change wheels, all I have to do is update a constant in my program, or if I change motors, I can then update a constant for that. But this is going to help me get there. If you've done any factor label or dimensional analysis, this should look fairly familiar. So I want to know how many ticks are equal to 60 inches. So I'm going to convert inches to rotations, and then rotations to ticks. So if I look here, for every one rotation, I have a certain number of inches that it travels, and that's the circumference of the wheel. So this is one rotation, is the circumference of the wheel. And then ticks per rotation is this value right here. There's 240.448 ticks per rotation for my wheel. If I'm going to put this in Robot C language, this would be ticks equals, now this value is actually my distance. So if I look over here, it is my variable dist. I'm going to put that variable right here. So this is equal to dist times this, which is a constant. This is going to be my tick constant divided by my wheel circumference. So this is the equation that you're going to see in my Robot C file. So go ahead and pause the video, make some adjustments in your code, add some constants into your code for whatever wheels you're using and whatever encoders you're using, and then plug in a distance variable, and then try to get this equation in. And this equation is going to be right above the while loop. We need to assign what ticks is before we then read what ticks is there. So this is going to go, this equation is going to go right one line above that while loop. So pause the video, try that, and then come back. Alright, so let's take a look at the code here that I've written. Again, I've put together some constants here called wheel diameter and wheel circ for wheel circumference, and my wheel diameter is 2.75 inches. Again, I just put a little comment that it's in inches. And the wheel circumference is the diameter times pi. Again, it's measured in inches. And then I have a tick constant that is 240.448. And again, this is for the 269 motor with encoder for that. And right now I have a variable called ticks, which is equal to 1,000. And we're going to get rid of that. Tick stays, but we're not going to assign it at that point. And then I'm going to have another variable called dist. I have my motor speed. So these are all global variables. These are kind of like constants. The other thing that I like to add into my code are some headings like this to kind of separate so you can kind of see some program flow. Like this. And then in some future videos, we're going to add some functions here. So we're going to have some other things that we're going to add to this. But this is good for now. This kind of gets us set up so we can kind of put things in place. And then right above my while loop, this is what we talked about. Ticks here will be equal to dist times, and then we're going to multiply by the tick constant and divide by the wheel circumference. And what this is going to do is it's going to automatically calculate the number of ticks required for a given distance that I assign. So if I want my robot to go 5 feet or 60 inches, again, not measured in inches. This would then cause my motor to go exactly, or my robot to go exactly 5 feet. Within the while loop, I have my P loop for the motor speed, which is this section of the code, and then I also have the auto straight portion of that. And then outside the while loop, if it gets to that tick value, then it stops the motors. So this is how you set up your program to now go a certain distance, which is measured in inches. So if I want to go 4 feet, I change this to 48. If I want to go 8 feet, then I can go 96. So this then allows you to change that, and it recalculates ticks every time and puts that value in here. Have a good day.